Now we can talk about the combined gas law. So let's put them together. We've got P1V1 equals P2V2, and we've got V1 over T1 equals V2 over T2. And I'm not going to attempt to prove this at all, but if you can put them together to get P1 V1 over T1 equals P2 V2 over T2. And what I'd like to say now is that in problems where you have lots of pressure, volume, and temperature conditions, but no mention of moles or gases, moles or grams, moles, it will of course mention gases. Then the combined gas law is oftentimes the gas law that you need. You can use it as long as, with any units, as long as the units are the same on both sides. And let's see, I guess the only thing they might mention is that moles are constant, but no actual numbers of moles. Here's an example that helps us to think about this combined gas law. If the temperature of a gas sample doubles while the volume remains constant, what happens to its pressure? So this is a thought-provoking question, and it is going to use the ideal gas law, the combined gas law. Okay, so it says if the temperature, let's talk about the constant. The volume remains constant. So V1 equals V2, and when two things are equal, we can cross them out of our equation. And now we're down to a easier thing to work with that says P1 over T1 equals P2 over T2. And there's lots of ways to deal with this, but one of them is, say, if the temperature of a gas sample doubles, and what I like to do is, so T1, let's just call T1 1. It technically means 1 Kelvin, but it's an easy number to do math with. And then P2, so the temperature doubles, 2. What happens to its pressure? So what can we say about P2? And what we can say is by cross-multiplying, 2 times P1 equals 1 times P2, or just P2. So what we can say, what happens to its pressure, is that pressure doubles. Pressure doubles. And one of my problem-solving techniques is that I like numbers in equations because I can think about them. So I plug in any numbers that allow me to figure what the trend is. Here's another one. If the volume of a gas sample doubles while the temperature remains constant, what happens to its pressure? I will return to the combined gas law. I will say temperature remains constant. And now, if the volume of a gas sample doubles, so V1 we're going to call 1, V2 we're going to call 2, so volume has doubled. And now P2 equals P1 divided by 2, so pressure is cut in half.